Good morning, good afternoon, good evening, or whatever the time is or the current time is when you're watching this. So, I am Maria Angela Dionisio, and this is for my ECEA 101-1 project.
I am Maria Angela C. Dionisio. And with the student number of 201810849 of ECEA 101-1 of section E01.
And today, I am going to discuss this circuit, which is the common emitter, which is the amplifier frequency response. And in this video, I am going to determine the voltage collector, the voltage bias, voltage emitter, and the voltage output, as well as the bandwidth. I'm going to get the waveform showing the voltage frequency and the phase shift. And this is how I made the circuit. Now, I am going to get the values of the voltage collector emitter based on the voltage output by clicking Simulate, Edit Simulation CMV or Command, DC Opt, PNT, and then clicking OK, then Run. Now, we see the list of values in the circuits I created. And it shows the values of the voltage base, the voltage collector and the voltage emitter, as well as the voltage output. And then we copy these values to see later for the waveform. And then we proceed by showing the waveforms by clicking simulate, edit simulation CMD, AC analysis, and then for the type of sweep we will have decade, and for the number of points we will have 101. The start frequency will be 10, and for the stop frequency we will have 100 meg. And then we click OK, and then we run. So we click the VC, and this is the waveform of the voltage collector to see the frequency of the voltage collector. In order to see this, or to have an exact measurement, or to have a precise measurement, we click this grid. And zoom in, and now we have to make this into linear, and then we zoom into 16 here, 16. So I have to zoom in the 16.4 in the VC because that is what we got in the list. Oh no, in the list a while ago. Here, there, in the VC there, and it shows that we have frequency in about 16.2 hertz, where in its phase shift it is about 231 degrees. And next we get the waveform of the voltage output, and we click the V out to determine and make sure it is in linear. And this is how to determine the voltage gain. This is the waveform of the voltage output, and this is how to determine the voltage gain, and it is approximately 49 with a frequency of 1 kilohertz to 100 kilohertz, and the phase shift is approximately 100 degrees. Now we find the gain. Next we have to find the gain decibel. Now we have to right click and choose decibel, and in here we have 33.745 decibel, and we add it here in our list. Our gain dB, which is there. Next, we have to find our frequency values, which is our frequency values which has the equation of gain decibel minus 3 decibel,
which is
F3 frequency value, or you can just put space, which is equal to our gain dB is, wait, let's look. Our gain dB is this one. Let's copy. There, minus 3 dB, which is equal to 30 there, about 30.745516 decibel. And we go to 30.745 7455. Wait, make sure this is in decibel. Yes. There. So we mark this as our frequency low, and our frequency low is 44.828201 hertz. Our frequency low here, our value here doesn't have to be exactly 30.7455. As long as it's near, that's fine. And then we copy this, and then list this as our frequency low. And then to find the frequency height, we have to find again 30.745 7455. There, and we mark this notes and notation and label. And this is our frequency high, or FH, and we list this as well as our FH. In order to get the new values or the new circuit, we have to right click, that is what I did, and 1 over IV1. So this is our new circuit, and make sure that this is in linear. And our circuit, or this should be in 10 hertz, our value a while ago, our FM, which was in about 10.10. So this is the closest. So our frequency is 10.092603 kilohertz, and our magnitude is 5.306. So let us list this. So our frequency is that, and our magnitude, let me just close this and then copy this and then insert it here. So next we get our V out, or rather R out, wherein we have two
You have to move this. This one. Or rather that. Here.
and do the V out, and then we connect it. There. And then in here we connect a ground. And then again we run this, we close, and then we run, and we click this, and then for our V out, again we have our 1 AC, and then we edit this, right click, and then 1 over IV1. And then our formula is, for R out is equal to V out over I out, and for V out, as we saw a while ago, our V out is still 1 AC, and our new equation will be 1 over IV1, which is I out. And then, so the R out, the R out's frequency is 10.073307 kilohertz, and our magnitude is 59.88. Oh, sorry, one moment. Let's just put this here. This is supposed to be linear, and yes, with this value, this is our frequency. Let's insert it here, and our magnitude for our out is 986.53308. So we copy this and insert it here. So these are our values, all the listed values. So in conclusion, all in all, what we found out in this circuit is that our bandwidth is 1549254.172 hertz, and our output is 986.53308. So thank you for listening, and if I did anything wrong, or if you have any corrections, please do correct me down below on the comment section. Thank you for listening on this short explanation on how to get the bandwidth, the RN and the R out, and the phase shift. That's all. Again, I am Maria Angela C. Dionisio with student ID number 2018100-849, a student of ECEA 101-1L of Section E01. Thank you.